Hey, welcome. So you've definitely seen this before, right? You ask an AI something and it fires back an answer that sounds just incredibly sure of itself. But here's the big question. Should you actually trust that confidence? Well, let's dive in and figure that out. It's kind of wild, isn't it? An AI just gives you this perfectly polished, confident answer, no hesitation at all. But is that confidence the real deal? Or is it more like an illusion? That's exactly the illusion we're going to unpack today. You see it everywhere, in the news, in ads. AI is painted as this magical, all-powerful thing. It's smarter than us, it's going to take all our jobs, it can't possibly be wrong. But when you actually peek behind the curtain, you start to see that this popular image, well, it's a bit of a misunderstanding. So let's do just that. Let's separate the hype from the reality. Because to really get a handle on AI's confidence, we first need to understand what's actually happening under the hood. When you boil it all down, an AI is basically a superpowered pattern recognition machine. It learns by churning through huge, and I mean huge amounts of data, pictures, text, you name it. And it just gets really, really good at figuring out what things usually go together. That's why it's so brilliant at telling a cat from a dog in a photo. It's seen millions of them. But this brings us to the first really big issue, something we can call the single model's illusion. And this, right here, is where that false sense of confidence really comes from. Okay, so most of the AI we bump into every day uses what's called a single model. Just think of it like one single brain. It's trying to weigh all the possible answers to your question all at once, and then it has to pick what it thinks is the most likely one. And what does that single model give you at the end of the day? It spits out a really clean, decisive-looking number just like this. It'll say, with total authority, I am 70% sure the answer is A. And that feels so precise, right? So trustworthy. But let's just pause here for a second. Let's ask the critical question. Is that 70% really a measure of how confident the AI is? Or is it something else entirely? And here's the big reveal. What looks like a real, genuine confidence score is actually just an internal calculation. It's been all tidied up and formatted to look like a nice, neat percentage. It's not a true statistical probability, which means it offers zero guarantee of quality or reliability. That 70% could honestly be based on some pretty flimsy evidence. So why does this all matter? Because, let's be honest, the real world is messy. It is rarely a simple choice between A and B. Let's look at a perfect example. Think about this. It's a very human situation. You see someone smiling, but at the same time, they have tears streaming down their face. So are they happy? Are they sad? The real answer is they're kind of both, aren't they? We actually have a name for this kind of thing, a double label situation. It's where two totally different realities are true at the exact same time. And this kind of nuance is precisely where single AI models just completely stumble. Just look at the difference here. The single AI model, it's forced to pick one. It sees the data, it weighs the options, and it says, okay, smiling is the winner. So it just throws away the sad label. A human, though, we get the nuance instantly. We understand they are both smiling and sad. The AI loses all that richness. So if a single model is the problem, what's the solution? Well, it turns out there's a lot of strength in numbers. Or, to be more specific, there's strength in having many models. The multi-model approach is actually pretty simple and elegant. Instead of one AI brain, you use several. So for a person who's crying and smiling, you might have one model that's trained only to spot smiles, and a totally separate one trained only to spot sadness. You show them both the exact same photo, and then you just listen to what each one has to say. And suddenly, bam, you get so much more useful information. When all the different models agree, that's when you have a truly confident answer. But when they disagree, that disagreement itself is an incredibly valuable signal. It's telling you, hey, there's some uncertainty here, or this is complex, just like in our smiling but also sad scenario. Now, this isn't just some technical, nerdy detail for engineers. Understanding the difference between these two approaches is absolutely critical when we start moving from looking at simple numbers to deciding what we can actually trust in the real world. Because in fields where the consequences are really serious, just getting the right answer, well, that's not good enough. We also need to know how sure we are about that answer. We have to know what we don't know. I mean,
Just think about it for a second. In medicine, a doctor needs to know if a sign of a disease is a strong signal or a really weak one. In a courtroom, a judge has to understand the level of uncertainty. In finance, one bad call can be a total catastrophe. In places like these, a single model's fake confidence isn't just unhelpful, it's dangerous.
Here's a really simple way to remember all this. The answer you get from a single AI model, think of it as an opinion, but the consensus you get from many independent models working together, that's much, much closer to a considered judgment.
So, I'll leave you with this to think about. The next time an AI gives you one of those super confident sounding answers, remember to ask yourself not just, is this right, but also, how can I possibly know how sure it really is? Because understanding that difference, that's the key to using this incredible technology wisely.